Here are the notes for how to find the trig ratios when the radius is not 1. You should probably pause the video and write all that down if you haven't done that already in class. But what we're going to do, the first step is you have to determine what quadrant you're in. And you're going to be given a couple different pieces of information to help you figure that out. And you use the process of elimination for that step. In the second step, we're going to use the Pythagorean theorem and the given trig ratio to find the missing value. We're either going to be missing x, y, or r. And then once you find all the values, you list all 6 trig ratios using them and the trig ratio definitions. And then you check the signs to make sure that they match the quadrant that you said your answer should be in. So our first example is going to be a little bit easier, okay, because it's just giving us a terminal point. We're going to do this one. It's just giving us a terminal point, and it's telling us that the point 3, 4 is where the end of the circle is. So there's a circle with a radius of 3. Or no, I'm sorry, it's not a radius of 3. There is a circle that looks like this. The angle is being rotated about the origin, and that's the point that we're going to find. So we can draw a triangle, and you always draw it so that you have a right angle on the x-axis. So since this is in the first quadrant, we know all of our trig values should be positive. Since this is x, that distance, that side length is 3, and since this is y, this side length is 4. And we could use the Pythagorean theorem to figure this out. It's x squared plus y squared equals the hypotenuse, which we're going to call r squared. And so this would be 3 squared plus 4 squared equals 5 squared. So on the harder problems, you would need to do this, but you also can recognize that this is a special 3, 4, 5 triangle. So in the end, r is going to equal 5, and you would just work that out and you get the same answer. So we have figured out that we're in the first quadrant and r is 5. So now we're going to use all this information. So x equals 3, y equals 4, and r equals 5. The value of the definition of sine is y over r. On the unit circle, r was always 1. But in these problems, we're figuring out, using the Pythagorean theorem, we're figuring out what r is. And in this case, r is 5. So y is 4, and r is 5. So you just write it using that definition. Cosecant is the reciprocal of sine of theta. So the reciprocal definition is r over y. R is 5, and y is 4. So you can probably do cosine as long as you know the definition. The definition of cosine is x over r. So since x is 3, r is going to be 5. The reciprocal definition for secant, r over x, we are going to get 5 over 3, 5/3. And tangent is y over x. Tangent is 4, or I'm sorry, y is 4, and x is 3. Cotangent is x over y. X is 3, and y is 4. Now, since this angle is in the first quadrant, we know that all of our trig functions are positive. And we talk about in the reference angles how to determine which quadrants have positive and negative angles or trig functions in them. So they all should be positive. You don't have to write it, but for emphasis, I'm going to go ahead and put the plus signs in here to help you remember to make sure that you check the signs. The next example is going to be one that has a little bit harder question with it.